multiple options to connect these two sites together. Let's suppose here my LAN subnet is 192.168.1.0/24. Here my LAN subnet is 192.168.2.0/24. I can connect it through internet, through public transport. I can connect it through MPLS. I can use any public transport here, right? Even you sometime you can use your own fiber cable as well between two sites or between two data center. I'm assuming this is my branch 1, and this is my branch 2, another side, branch 2. Okay, let's suppose I have connectivity, WAN connectivity from ISP in Airtel, like Tata, Airtel. Okay, so let's suppose this is Tata, one ISP connected with my edge router R1. So R1 is connected with LAN and WAN. Similarly, here also you have to connect your router, edge router to ISP network. Here my ISP can be Tata or Airtel, Jio, right? Let's suppose here this is Airtel, and we know all the ISPs are connected together. That is internet. Internet means network of networks. Multiple ISPs are connected together through internet. Here we have internet in between, right? So ISP will give you the public IP address here 1.1.1.1. Here let's say 2.2.2.1. Now these two public IP addresses will be reachable with each other because both are public IP addresses. Yes, but you can ping 2.2.2.1 from 1.1.1. Yes or no? That's not our concern how these two public IP addresses are reachable. But can we forward traffic from branch 1 to branch 2, from this LAN to this LAN? No, we can't forward, right? Because by default private and private cannot communicate over public. Two or more private sites cannot communicate with each other over public network. Then how we will make communication?
Will perform NAT.
Through VPN.
We can use NAT.
Not NAT. NAT is used to make communication between private and public. If you want to access internet, you will configure NAT. NAT is a technology which allow you to access internet public subnet with the help of private IP address. NAT is going to translate the source, private source, into public IP address. Here we are using another technology, that is VPN. VPN stands for virtual private network. This is a private network, virtual private network. We are going to configure like this. With the help of these two public IP addresses, like here you can see 1.1.1 and here you can see 2.2.2.1. As these two public IP addresses are reachable, we can configure here VPN with the help of these two public IP addresses, and then it can communicate. It can be IPsec VPN, it can be GRE VPN, right? It can be on the MPLS transport, it can be L2 VPN, MPLS L2 VPN, or MPLS L3 VPN. In SD-WAN, SD-WAN supports GRE and IPsec VPN. So manually here on both the router you are going to configure either GRE or IPsec VPN. Here you will configure one IP address. Let's suppose 10.1.1.1/24 or /30, and here 10.1.1.2/30. Now you can see the tunnel VPN interface on both the router, right? Both are at different sites, at different location, but still both are in same subnet 10.1.1.1, 10.1.1.2. Both the IP address belongs to same subnet. Means my subnet on this VPN is 10.1.1.0/30. This is my subnet for VPN, for virtual private network. And now here we can configure any dynamic routing protocol to perform routing between branch 1 and branch 2 for LAN prefixes. And after that, side 1 and side 2 can talk with each other. correct? All the traffic will go through VPN. This is how we were making reachability between two sites before SD-WAN. In SD-WAN also there will be VPN between sites, but you are not going to configure any VPN. Automatically it will establish IPsec VPN by default. IPsec. If you want GRE, you can change the protocol. By default protocol is IPsec, right? Okay, that is fine. Here once I will onboard all the router, you can see I have how many branches here? 4 branch 1, branch 2, branch 3 and DC, means I have total 4 sites. Between all the sites SD-WAN is going to establish IPsec, right? Now here you can see, if I will talk about the overlay topology, then my overlay topology is connected like this: R1, R2, and connected with one VPN, IPsec VPN, and IP address over this overlay interface is 10.1.1.1. Here 10.1.1.2. What is this? This is overlay topology, right? Of the previous like above topology. This is underlay and this is what?
Overlay.
Overlay. SD-WAN is overlay technology, right? So you will see after onboarding, you will not see any transport like this transport information or what IP addresses are running over here, the underlay. SD-WAN is going to create their own topology like this, like the lower topology. Between router I have VPN. Here I have 4 sites. So in between 4 sites, let's say DC, branch 1, branch 2, branch 3. All the routers will have IPsec with each other like this. This is what? This is your SD-WAN topology. Got it? For data plane. If branch 1 and branch 2 want to communicate, they will communicate directly through this IPsec. This is DC router. This is branch 1 router, branch 2 router, and branch 3 router. See what I have told you here. Now I have one LAN subnet 10.1.1.0/24. So what I told you here, you have to configure now routing. You can run any dynamic routing protocol on the VPN to exchange, to perform routing between branch 1 and 2, correct? Similarly here, we need to advertise this LAN subnet which is connected in branch 1 to other site, correct? Here we have what? Right, dynamic routing protocol. I can configure EIGRP, yes na? EIGRP. I can configure OSPF, I can configure BGP, or I can configure ISIS. Even I can configure the RIP routing protocol. But in SD-WAN, you have single routing protocol, that is OMP, overlay management protocol. So all the SD-WAN protocols are overlay. First of all, understand the difference between underlay and overlay. Earlier in the legacy WAN also, we were our technology, the technologies which we were using to make communication possible between multiple private subnets over public network was overlay only. MPLS L2 VPN is also overlay. MPLS L2 VPN is also overlay. IPsec is overlay. GRE is overlay. DM VPN overlay. All are overlay technology. Overlay is what? Overlay is a virtual network which is running on top of physical network. Underlay is the core network underlay, right? Which you can see, like this is my underlay, and overlay the virtual network which is running on top of underlay. So if there is any issue in underlay, my overlay will automatically goes down, right? If let's say this IP address 2.2.2.1 is not reachable from 1.1.1, will this IPsec tunnel work? No.
No.
Overlay will only work if there is underlay reachability. In SD-WAN also, first task is making underlay reachability. First you have to make reachability between all the routers, like whatever IP address you are going to configure over here on G0/0 or VS1, and VH2 G0/0. They should be able to communicate ping. IP address should be pingable. That means there is underlay connectivity. When you have underlay connectivity, you will configure SD-WAN.
So routing protocols is underlay or overlay?
Which routing protocol? These are
Yeah,
underlay protocol.
BGP
See,
underlay
routing
protocol.
routing protocols are not underlay or overlay. These are routing protocols used to exchange the routes between the prefixes. Where you are going to run the routing protocol, you can run it on the underlay network as well as on the overlay network.
Overlay.
In both cases, we
Okay.
can configure the dynamic routing.
Okay. Thank you.
Overlay means the virtual network which is created on top of physical network, underlay network. One is physical, one is virtual. Anything else?
Yeah, I have a question.
Go ahead, go ahead.
Okay, my question is you talked you said something about SD1 that SD1 does not require um the legacy routing protocol for it to work like OSPF and the rest of them, that it only um need the OMP to um to run. So I'm asking, the question that I want to ask is this: on the side of the LAN, is there a need to still run a routing protocol?
Definitely. See, let's say in SD-WAN, this is your router, SD-WAN router, VH. And behind VH, you have one internal router, VH1. And then I have one Cisco router, legacy router, let's say. And behind the router, I have LAN subnet. Here, my LAN subnet is 10.1.1.0/24, which is running behind the router number 1. So, how you will advertise this TAN network from R1 to VS? Here you can configure any dynamic routing protocol. You can run OSPF or you can run BGP routing protocol. But OMP will work between the SD-WAN routers. Right? VH1 is going to advertise this prefix to other side, to VH2. Let's say I have another side somewhere VH2. So VH1 will advertise this TAN subnet to VH2 through OMP. Between VHs, how route will exchange through VS Smart. There is one VS Smart, that is your centralized control plane, right? So VS1 is going to advertise this TAN subnet to VS Smart through OMP protocol. First, router 1 is going to advertise this network to VS through OSPF routing protocol. Now OSPF routing protocol is going to install this prefix in the routing table of VS1. VS1 is going to advertise it to VS Smart through OMP, right? Here we have OMP session, overlay management protocol. We'll understand the OMP protocol in detail. And VS2 will also have OMP session with VS Smart. All the routers will have OMP session with VS Smart for control plane. So see, VS Smart is learning some prefix from one neighbor, definitely it will advertise to another neighbor, exactly like OSPF.
Okay.
Right? In the legacy time, we were using all the routing protocol. We were configuring all the routing protocol on all the router because control plane was distributed. Router 1 has their own control plane, router 2 has their own control plane. Router 1 has their own management plane, router 2 has their own management plane. But in SD-WAN, we have centralized control plane and management plane. You will have single VS Smart and lots of VSs. These are only data plane. That's why sometimes what we are saying SDN is decoupling of control plane, data plane and management plane. SDN is decoupling all the planes. So earlier, if all the planes are residing inside the single box, even device box is going to be costly, yes or no?
Yes.
Right? So that's why we are saying SD-WAN is a cheaper solution. Let's suppose you have a network like in branch 1. This is my design. but in the production you will have not like connectivity like this. Actually you will have multiple core layer routers, R1, R2, then multiple distribution layer switches, D switch 1, D switch 2, then you will have multiple access layer switches, right? And you are going to connect devices like this. This is one side, one branch. So you can see how many devices I have here. 4, 6, 8. Total I have 8 devices. Means how many management planes are there? 8 management plane, right? If you are the network admin of this company, right, sitting somewhere in the NOC, and you need to change the SNMP IP address. Let's say on all the devices earlier SNMP IP address was 100.1.1, and now my SNMP IP address is changed. New SNMP IP address is 200.1.1. How you will do that? You will access all the router through SSH, right? First you are going to access R1. You will take console. You will access what? R1 through SSH, and then you will apply the command. You will close the connection, then again you will access R2. Again you will apply the command and you will terminate the connection. Then you are going to access distribution switch 1. Again you will access through SSH, then apply the command. Close the session, access distribution switch 2. Apply the command, close the connection session. Then distribution switch 1, distribution access switch 1, access switch 2, access switch 3, access switch 4. Like this we were configuring, correct?
Yeah.
If I have 100 sites or 1000 sites like this, then imagine just changing one SNMP IP address is going to be difficult task, time consuming task. A team is required. We have to divide the task into team, right? So management was so poor in the legacy WAN. And when we have multiple sites, let's say I have one data center, DC, branch 1, branch 2. Let's say 2 branch only. I'm making the topology simple for now. And there is internet transport. Internet is costly transport or cheaper transport?
Keeper.
Internet is cheaper but not reliable.
Yeah.
Internet
Yeah.
is cheaper but not reliable, less reliable. I have one more transport, that is MPLS, costly but stable. MPLS transport is costly but reliable. Earlier in the legacy time we were using both transport, internet and MPLS. MPLS transport was mandatory. Sometimes people are saying SD-WAN is the replacement of MPLS. Definitely no. MPLS is a transport, right? It is not a WAN technology. SD-WAN is a WAN technology used to make communication between multiple sites. As MPLS is a transport, right? Costly transport, but reliable transport. Costly but reliable. Now let's say I have one DC site, branch 1 and branch 2. 3 sites are there. If I am going to connect all the sites through internet transport. Now over internet you have to configure what? VPN. You know this, between DC and branch 1, between DC and branch 2, or between branch 1 and branch 2 also. Like that depends on your scenario. If you want full mesh topology, you need VPN, one VPN over here, one VPN over here, one VPN over here. This is full mesh topology. If you want hub and spoke topology, one VPN here, one VPN over here. This is what? Hub and spoke topology. Now let's suppose behind the DC I have LAN subnet 10.1.1.0/24. Behind branch 1 I have LAN subnet 20.1.1.0/24. Between behind branch 2 30.1.1.0/24. After creating VPN, all the sites, all these LANs can communicate with each other without having any issue. Through which transport? Through internet transport. And our all the company applications like ERP application, right? A company portal, everything was hosted in data center. Data center devices connected with one switch, and here we are hosting our applications. Here my all applications are hosted. Now tell me one thing. Here we have some applications, company applications, right? So the branch users need to access these applications multiple time in a day or in an hour. How they will access? They will access through internet transport, through VPN. Now understand the issue. Can branch user, let's say 20.1.1, access internet? You have to configure. Praphul, if you will configure internet, definitely they can access. But is internet secure?
No.
Can I send my company traffic to internet directly from branch 1? No. I need what? Firewall. If you want to send traffic on internet, you need one firewall over here. Firewall will inspect the traffic. Inspect means firewall will check who are you, what is your source IP address, where are you going, what is your destination IP address, right? Let me check the policies, you are allowed or not. If you are allowed, then only I will send, otherwise block. It will block all the viruses, malicious traffic, right? So we need firewall. If a company has 1,000 sites, they need 1,000 firewall. They need lots of security engineers who will manage the firewall, who will configure the firewall, who will configure VPN over firewall. So company was using centralized firewall mechanism. Centralized firewall mechanism means we were not configuring direct internet access on branch routers. We were using a centralized firewall in DC. Let's suppose in the DC I have one firewall. I have installed this, and all the branches are going to use this firewall. This is my centralized firewall. How? If branch 1 user or branch 2 user want to access internet, how they will access? They will first reach to DC through VPN. In the DC we have firewall. Firewall will inspect the traffic and then it will send to internet. Let's suppose it is connected to internet also. This is dedicated internet. Here my internet is internet transport. There is some difference between transport and internet. Accessing internet. Accessing internet means internet service. Here I have internet service, and here my ISP is just connecting multiple sites. This is not internet access. This is not service, internet service. Internet is here like this. Now if branch 1 user want to talk or access internet, then first traffic will reach to DC through through internet transport. Then router will send to firewall, firewall will send to internet, and in the same way reply will come. This is how they will access internet. How they will access the application, company application? They will reach to DC, and in the DC we have applications. Again through firewall you can forward the traffic to applications. Good, everything is working well. This was our legacy infrastructure, but still one issue. Some application needs minimum delay. Let's say there is one app 1. Their delay should be, there is requirement, delay should be less than 50 millisecond, and internet is not reliable transport. So you have some business critical traffic, some business critical applications. For that you can use costly transport, MPLS, which is more reliable than internet. Not for all the traffic because it is going to be costly. So you will send all critical traffic over MPLS and general traffic over internet. But even in through internet you can use it without using MPLS also, you can use it, no problem. But issue is here when our applications are not in the data center, when our applications are in cloud. Now what happened nowadays, we have shifted our applications over cloud, AWS. Now how AWS is reachable? Through internet only, correct?
Yeah.
All the clouds are reachable through internet. Now see, branch users was earlier accessing company's application like this. It was sending traffic to DC through internet transport. Then in the DC, there was applications. All the applications was hosted in the DC. Now all the applications are hosted in cloud. Now how they will access the cloud application? First they will reach to DC through internet, through VPN. Then there is firewall. Firewall will inspect the traffic, then it will send to internet. Internet will send to cloud application. Here when we started deploying our application our cloud, branch user started getting latency issue of performance, started getting latency issue, performance issue. Now how company can avoid this? Company has started using MPLS transport for all the cloud application. Now you will reach to data center through, all the branches will reach to data center through MPLS transport. That is the costly transport. Now it is going to increase the cost of companies, yes or no?
Yes.
And from the DC they will access cloud application through internet. So using MPLS transport was the mandatory in legacy time when we don't have SD-WAN, so that branch users can reach to data center quickly through MPLS transport. This was the exactly infrastructure which we were using before SD-WAN in the enterprises. Praful, here is the internet connection. Why not branch users can access cloud application directly? You need firewall here, you know this, right? So
Yeah.
all the traffic will reach to DC, right? For applications, all the traffic will go to DC via MPLS and then to the internet. Here what is the issue? Number one, costly transport. MPLS is a costly transport and we are forwarding huge amount of traffic over here. Our MPLS, we need good bandwidth. Second, still some applications are buffering because traffic is following the longest path. My traffic is going to DC and then to cloud application. Performance issue, latency issue is still there even after using MPLS transport. That's why companies are moving to SD-WAN. SD-WAN allow you to access internet directly without having firewall. You don't need to install any firewall over here. Just replace this router, the legacy router, with SD-WAN router, that is VS or CS. All the firewall features, input features are already integrated there. That allow you to access internet. So directly branch users can access cloud application like this. It will come here and then here to here. Otherwise, let's imagine this branch is in India, my DC is in London, right? And I have some application over cloud. So if anyone from the India want to access the cloud application, first they will go to London and then again maybe they will come back to the India AWS data center. That was the biggest issue. One issue in the last class I had shown you, a smart failover on the edge router. In legacy WAN, failover was happening when complete connectivity was going down. Not in case of reliability issue, performance issue, latency issue, slowness issue, packet loss. In that case, your router was not performing load balancing. SD-WAN has capability. It will be keep monitoring the quality of WAN link through BFD protocol. BFD is link liveness protocol, bidirectional forwarding. Even you guys had used, maybe you have used BFD with OSPF in legacy network as well, right? So BFD is not a new protocol, but here SD-WAN is going to use BFD for monitoring the link quality. And based on link performance, based on real-time data, SD-WAN is going to choose the path, best path. Here manually you have to shift the traffic. Let's say sometime if MPLS is not behaving well, not working well, then you have to shift the traffic over internet. Sometime internet is not behaving well and MPLS is behaving well. You have to manually fail over, shift the traffic. But SD-WAN is capable to do that automatically. You don't need to do anything. You will see the monitoring, management, configuration, everything is so easy. SD-WAN is cheaper solution, and policy is the great. SD-WAN policy is great, right? Like path manipulation was difficult in the legacy time, in the legacy network, legacy WAN. Manipulating path, route filtering, monitoring, configuration, management, everything was poor, complicated, difficult. In SD-WAN, we have easy, user-friendly dashboard. From the single dashboard, you can manage your entire topology, entire fabric. Now question is how, Praful? Now question is how? Any question? Clear?
No.
Clear? Right? This was the exactly infra before SD-WAN for in the enterprise.
One quick question,
Go ahead.
Praphul. So you have a connection to internet and also iNet. So it means that so the users at the endpoint will not able to connect to the internet IP address, only to the branch. So that is what it is, right?
See what I am saying. Understand one thing, and we can have one small lab as well. That will be great. Let me do one thing. Let me create one a small lab for you guys. Mm, I can say enterprise network. Let's say I have 3 sites, so I'm going to use 3 routers. Let's have a small lab. It will help you to understand the issues in more detail. Let's say I have 3 sites. One is DC, one is branch 1, and one is branch 2. Three. And I have one transport over here, that is internet transport. Then I will add MPLS transport as well. First, let me add the internet transport. iNet. You all know the GRE, guys. GRE and IPsec. Here very quickly I am going to configure GRE
Yes.
VPN between all the sites. In the SD-WAN topology, policies, I will show you how you can create hub and spoke topology, how you can create full mesh topology. By default, it will create full mesh topology. All the sites will have IPsec with each other. Let's suppose this is my topology. Let me start the devices. And here I have one LAN 10.1.1.0/24, 10.1.2.0/24, and 10.1.3.0/24. Size 15, bolt. You guys can also try to configure this lab before SD-WAN. It will be better. Here I have some LAN 20, 20.1.1.0, 20.1.2.0, 20.1.3.0, and here 30, 30.1.1.0, 30.1.2.0, 30.1.3.0. I want these all LANs should communicate with each other. And on the underlay, your IP address is, let's say, public IP address. Here your public IP address is 1.1.1 underlay. You will say underlay doesn't matter for us in SD-WAN. 2.2.2.1 and 3.3.3.1. On the internet router, I will configure .2. Internet side, I will configure .2, and on my router I will configure .1. Just to make you understand the VPN, how it was working in legacy way, so that you can understand SD-WAN more detail. So command is enable config t interface g0/0 no shutdown IP address 1.1.1.1 exit, and LAN interface loopback 1 IP address 10.1.1.1 exit. Like we say loopback 2 and loopback 3. Loopback 2 IP is going to be 10.1.2.1. Loopback 3 IP is going to be 10.1.3.1. Copy. Let me paste it on R1. See, all the commands are accepted. Host name R1. Let me save the configuration. Okay. Let me configure R2. This is my R1 configuration. I can send the initial configuration to you guys as well. R1. Then my R2 configuration. On R2 G0/0 IP address is going to be 2.2.2.1, and here instead of 10 I am saying 20. Let me copy it, paste it on R2.
Can you try the simulation packet tracing? That will not work.
Yes, you can do that as you wish.
Okay. Okay.
Okay, now R3. For R3, here my IP address is going to be 3.3.3.1. Here 30. And 30. Let me copy and paste. Now how you will make reachability, underlay reachability between these three sites? Tell me.
The routing protocol.
No, for underlay you cannot configure routing protocol. Even ISP will not allow you to run any routing protocol on the WAN port. Right, this is WAN port. Here we cannot configure any routing protocol, sir.
A static router.
Even ISP is going to block all the private traffic over here on their interface.
VPN, VPN.
No, VPN is overlay. So probably
Definitely will create VPN for inter-site communication. I am talking about underlay.
you mentioned dynamic protocol, right? Before.
For underlay, here I can configure static routing, right? When
Oh,
like ISP will give you the IP address, let's say your router is getting IP through DHCP, it will get the default gateway as well, right? Default gateway is going to be 1.1.1.2. Here I can run command IP route 2.2.2.1, subnet mask 255.255.255.255, and exit interface G0/0, next stop IP address 1.1.2, right? To reach 3.3.1, I can have the route similarly like this, correct? And on the internet router also we need to configure IP addresses. On the internet router you will just configure IP address, nothing else. On router number 2 also I have to configure routing for 1.1.1 and 3.3.3 for underlay reachability for IP route 1.1.1.1 255.255.255.255 G0/0, and next stop IP address 2.2.2.2.
255.0, huh?
No, for individual IP address you will configure routing like
32.
this.
Okay.
Okay, on R3 also I will configure like this: IP route 1.1.1 255.255.255 G0/0 and 3.3.2 and one more for 2.2. Now I have underlay reachability between all the sites, right? After configuring IP address on the internet router, you can test the underlay connectivity. Config T interface G0/0 no shutdown and IP address 1.1.1.2 255.255.255.0 interface G0/1 no shutdown and IP address 2.2.2.2 255.255.255.0 interface G0/2 no shut and IP address 3.3.3.2 255.255.255.0. This is your hands-on before SD-WAN. Let me write the configuration. Host name, I need, right. Close the console of internet because we are not going to configure anything on internet router. Just I have configured the IP addresses. Now if I will verify the underlay, ping 2.2.2.1. Will ping work? Ping should work. You can see ping is working. Similarly, I can also ping 3.3.3.1. You can see ping is working. From router number 2 also I can check connectivity. Ping 1.1.1, ping is working. Ping 3.3.3.1, ping is working. Means all the sites are able to talk with each other through public IP address. There is underlay reachability, no problem. But can LAN to LAN communication possible? Here, not possible. Not possible here, right? Because router 2 don't know what is the route or what is the next hop IP address to reach in 37.10 subnet. This is underlay, just underlay. You have public IP addresses. All public IP addresses are reachable with each other. Even that is not our concern. That is concern of ISP. That is concern of ISP. That is not our concern. Here I want site-to-site communication between 3 branches. For that I have to create VPN. For VPN on router number 1, you are going to run this command, interface tunnel 1, correct? Then tunnel source. Tunnel source is going to be what? G0/0.
1.2.
Tunnel destination. Tunnel destination is going to be what? 2.2.2.1. And our mode tunnel destination. This is the VPN between router 1 and router 2. Tunnel source, tunnel destination. And after that, one more thing, IP address. On the tunnel interface, let's say my subnet is 172.16.1.1, 255.255.255.0. Now I can remove this underlay. I've saved the configuration, the initial configuration on all the routers. Let me write so that there is reachability, underlay reachability. Now for VPN, my underlay doesn't matter. Here I am going to configure what? IP address on the tunnel interface overlay, through which my multiple sites are going to communicate. Let me copy these tunnel commands and let me paste it over here on router number 1. This command is going to create one tunnel. So IP interface brief. You can see tunnel is created and tunnel interface is up. Similarly, I will create tunnel on router number 2 also. Oh my God. Tunnel 1, tunnel source will be same, tunnel destination will be 1.1.1.1. The peer public IP address and IP address on the tunnel interface is .2. Copy it, paste it on R2, router 2. Here we have what, guys? Now here we have now VPN between router 1 and router 2. Between router 1 and router 2 we have a VPN, and over that VPN My subnet is 172.16.1.0. Let me copy it. Let me paste in the notepad, sorry, paint, and here let me write the overlay. Now forget about the underlay. You can forget about the underlay. Here is your overlay, and IP address over here is 172.16.1.1, and here 172.16.1.2. You can see IP address on both the router is from the same subnet. Here we can configure any routing protocol. So let me add one routing protocol as well, router EIGRP, or whatever routing protocol you want to configure, router EIGRP 10 and network. First I will enable EIGRP on my terminal interface 172.16.1.0, and then network 10.1.0.0, wildcard mask 0.0.0.0.255.255. Here also I can define the wildcard mask 0.0.255 and exit. This is my EIGRP configuration on R1. Config T and run the command. So IP EIGRP interfaces. You can see EIGRP is enabled on all loopback interface as well as on the tunnel 1 interface. Right? So router 1 is going to advertise this network to their EIGRP neighbors. If I will enable EIGRP on router number 2 also, on router number 2 also I have enabled EIGRP. Okay, here instead of 10 I am saying 20. Let me copy these commands and let me paste it on R2. Now you can see we have EIGRP neighborship over which interface? Our tunnel interface. So IP EIGRP neighbor and so IP route EIGRP. You can see I got all the prefixes of DC branch 1. This is my data center. This is what? This is your DC. DC and branch 1 and branch 2. Let me write it like this. DC branch 1. Now see, branch 1 and branch 2 are able to communicate with each other LAN to LAN. From router number 1, if I am going to ping 20.1.1 and source 10.1.1, will ping work? Yes, ping is working. But can I access internet? Can anyone access internet?
No.
No one can access internet, right? Even DC and branch 2 cannot communicate. Here I have to get one more tunnel on router number 1. I am adding one more tunnel interface here for VPN between DC and branch 2. Or you can configure DM VPN as well, doesn't matter. Here let's say my destination IP address is 3.3.3.1 and subnet is 2.1. Let me copy it and let me paste it on router number 1 again, R1. And I am going to enable EIGRP on this tunnel interface also. Router EIGRP as number 10. Here in EIGRP you need to add one more network command. Copy it and paste it over here. Make it 2. Let me copy these commands and again I can run it on router. Good. On R3 you need to create one tunnel. Let me copy these commands and let me paste it on R3 for tunnel. interface tunnel 1, tunnel's destination is 1.1.1, great, and IP address is 2.2, and we need to enable EAGRP also, so router EAGRP is number 10, and network 2.0 and 30.1.0. Let me copy it, let me paste it on R3. Got it, guys? So IP EAGRP interfaces. You can see EAGRP is enabled on all the interfaces, even we have neighborship, so IP route EAGRP, done. And this router is finally receiving all the prefixes of DC as well as all the prefixes of branch 1. This is my branch 2. Now see, all the sites are able to talk with each other. On from router number 3, I can ping DC 10.1.1 and source 30.1.1. You can see it is reachable. I can similarly ping 20.1.1, source 30.1.1. You can see there is reachability. All the sites are able to communicate with each other, but no one is able to access internet, right? So it means what? It means this is transport, not the internet service. Here dedicated, you will have dedicated internet service. Let's suppose router, I have one internet in DC. My internet service is hosted in data center. Question is how you will configure the internet service, like how branch users can access internet. Praphul, wait a minute. Here I have to set R2, connect it, and then up the router. I've lost the configuration of R1, so let me copy the configuration of R1 again. Copy and paste it over here. Just it's loading. 1 minute. R1, paste all the commands, done. So IP route EAGRP. Okay, we are learning all the LAN prefixes of other sites, and here I am going to configure internet access now on R1, and same internet will be accessible from the branch users. Right now, whatever applications are hosted over cloud, that will be reachable through this internet. Got it? In the production, you will have multiple internet connections for the redundancy, for high availability. Here we have single internet connection because failover configuration and load balancing. I am expecting you already know this. If you have single internet or multiple internet, doesn't matter. On router number 1, I am going to configure now internet access. How I will configure the internet access? Interface G0/1, no shutdown, IP address. Let's say IP public IP address is 100.1.1, 255.255.255.0, exit. And for the internet access, you will configure default route, right? IP route 0.0.0, exit interface G0/1, and next of IP address 100.1.2. This is my default route for internet access. On this interface, you will also configure IP NAT outside for internet access for translation, and on all the loopback interfaces, you will add command inside. So here I can add one more commands, that is interface range loopback 1 to loopback 3 and IP NAT inside, so that my LAN users can access internet. Let me copy it and let me paste it on router number 1 R1 config T and paste the commands. All the commands are accepted. Now I need to configure internet router. Go to internet router here and just configure the IP addresses, nothing else. For the testing, what I am going to do, I am going to create one loop back on internet router. Let's say 8.8.8. 8.8.8. For testing, just I have created one loop back here. Now on the internet router, just configure IP addresses. Config T, host name, internet, interface, G0/0, no shutdown, and IP address 100.101.255.255.255.0. Interface loopback 1, IP address 8.8.8.8.255.255.255.0. Save the configuration and close the console. I am not going to configure anything else. Can LAN user from this subnet access internet? Tell me yes or no.
Yes.
Ping 8.8.8.8 and source 10.1.1. Ping is not working, sir. Because of NAT configuration. NAT is not configured, right? Access list number 10 permit any. Permit, and this is my ACL and IP NAT ACL to match source for translation. I'm expecting you know this NAT configuration. IP NAT inside source, match source from list number 10 and translate into the IP address which is running on interface G0/1 and use overload for PAT. Right, this is your NAT configuration. Do so history. Okay, I can paste the command here. Later you guys can go through these configurations. Right, and before this I had configured ACL access list number 10 permit any, which is matching all the source, but here in the ACL you have to match the private IP addresses. Carefully you will configure in the production. That is only matching the source. Copy it and paste it. Copy and paste it on R1. Okay, I've already pasted the command, no problem. Now if I am going to ping, then I am expecting reachability. Now you can see there is reachability. All the users from data center are able to access internet, but can branch users access internet? My question to you is this only. This is the reason why I have configured this topology. How can branch users access internet? Or if branch users are able to access internet, they can also access cloud application. How branch user will access 8.8.8?
Same configuration that we use in R1. Yes.
First of all, see what is happening here. My gateway means router number 2 in branch 1 is the gateway. Don't has route for 8.8.8. First you have to configure one default route here. You will configure default route on which interface? Tell me.
The exit interface of R2.
Will configure default route on the VPN interface, na sir? Right? Because see, internet is here.
Okay, okay.
Internet. So what I want, if someone who is sitting over here want to access internet, it will send traffic to router number 1 and router number 2, and router 2 should forward it to DC through this VPN. So I will configure default route on this VPN here. If you will configure default route on this interface, then your traffic will go in underlay, not over on the overlay. I want to forward internet traffic on overlay. not underlay, right? Because this is not my internet. Here is my internet. So I will send traffic, internet traffic to the DC. The requirement is different. So configuration is going to be like this. Let me write in the notepad directly. IP route 0.0.0, 0.0.0. Exit interface is tunnel 1 interface, and next hop IP address 172.16.1.1. This is your default route. And one more thing, on all loopback interface range loopback 1 to loopback 3, IPNAT inside, exit, and interface tunnel 1, IPNAT outside and exit. So these commands are required on router number 2 and on router number 3. What happened? There is some mistake. Okay. Here, remove it, copy and paste it on I2. Try to paste it now. Okay, this time all the commands are accepted. Now if I am going to ping internet, ping 8.8.8.8 and source 20.1.1. Will ping work? No, ping is still not working. Why ping is not working now?
You have to configure access system NAT.
No, that is configured on edge router na, in the DC. Here we don't need to configure. Here router 1 is going to receive NAT traffic, internet traffic on tunnel interface. So that tunnel interface should be configured as inside. On R1, here you have to add one more command, interface tunnel 1 IP NAT inside, so that it can perform translation. And now ping, and now you can see ping is working. How we are able to access internet? Internet is accessible through R1, through DC, correct? Internet is accessible through DC on R1 on the tunnel interface. I have added one more command here, that is interface tunnel 1 IP NAT inside. Very good. Similarly, we'll do same thing on router number 3 also. Let me copy the commands of R2 and let me paste it on R3. On R3, IP route tunnel interface 1, and next of IP address is going to be 2.1, interface loopback 1 to 3, IP NAT inside, and interface tunnel 1 IP NAT outside. Copy and paste it on R3. R3, got it? Now go to R2, because still R3 cannot access internet. Ping 8.8.8.8 and source loopback 1 not working. So on R1 I have to configure IP NAT inside on tunnel 2 interface, because router 1 DC router is going to receive internet traffic on tunnel 2 interface from branch 2. Interface tunnel 2 and IP NAT inside. Let me
Tunnel
ping
2,
now.
you mentioned tunnel 1.
Okay. IP NAT inside. And now you can see ping started working. All good. Now here, let's suppose from the branches when I am pinging, what is the delay here? Delay is showing 13 millisecond, the average delay. Let's suppose for some cloud application delay is more. I need more reliable transport. In that case, what you will do?
IPsec.
You will add the MPLS transport, IP NAT inside. You will add the MPLS transport. Let me close router number 1, router number 2 and router number 3 and add the MPLS transport here. Now internet transport is not sufficient. For some critical traffic, I am going to add MPLS transport here. Before starting SD-WAN, you can also configure this lab so that you can understand, like before SD-WAN, how our branches were accessing internet and cloud application. In SD-WAN, you can compare. This is my MPLS transport, and let's say all the routers are connected with MPLS transport also like this. On all the routers, I am going to add MPLS interface in the configuration, and let's suppose on the MPLS my subnet is, forget about the underlay, doesn't matter. Now we have VPN and that is working fine. Here is the, on the MPLS transport, let's suppose my subnet is 172.168. Here my subnet is 172.16.10.0/24. Here my subnet is 12.0 and here my subnet is, let's say, 11.0. What I want, some critical traffic should from the branches to internet go via MPLS and some general traffic should go via internet. Now that is my requirement. First of all, you have to add internet transport on all the router. Let me take you to the configuration file. Go to R1. On the R1, let's configure this newly added interface exit interface G0/2, no shutdown, and IP address 172.16.10.1 255.255.255.0 exit. That's it. I will advertise this interface also into the EIGRP so that EIGRP can work on MPLS also, MPLS path or whatever routing protocol you want to use. You know, our MPLS, we are configuring MPBGP, right, to make communication between multiple sites through VRF. That is exactly same. Now I am going to copy the command of R1 again and I will paste it on R1 after applying all the commands. Let me start the router, this router also, and this router is already started. On the R1, I am going to paste my all commands. R1 and paste it. All the commands are accepted. On R2 also I will add this interface G0/1 interface. Copy and paste under R2 configuration. Here it is going to be 0/1. And what will be the IP? 172.16.11.1. Copy it. Copy the command of R2. Paste it on R2. All commands are accepted. Great. Go to R3. And configure 12.1. Copy commands of R3 and paste it. All good. Now again from branch 1 I can try to ping internet, ping 8.8.8.8 and source loopback 1. You can see internet is reachable. Even I can trace route 8.8.8.8 and source loop back 1 numeric. You can see my traffic is going to DC first. Right, in the trace route you will not discover the underlay internet router because traffic is going through VPN. Traffic is going through VPN, right? We have direct virtual link between all the branches. Now I am going to enable EAGRP on MPLS interfaces also. Before that, let me configure MPLS router like only IP addresses. R3 is configured. Oh, yes, already configured. Great. Now let me configure MPLS router. IP addresses. Enable config T interface G0/0 no shutdown. IP address 172.16.10.2 interface G0/1 no shut and IP address 172.16.11.2 interface G0/2 no shut and IP address 12.2. And I am going to enable EAGRP on all the interfaces. Router EAGRP as number 10, network 0.0.0 for routing. Save the configuration of MPLS router. Host name MPLS. See, on routers on R1, I am going to add one more network command in EAGRP. Router EAGRP is number 10 and network 172.16.10.0. Good. Go to router number 2. Router EAGRP is number 10 and network 172.16.11.0. Go to router number 3. Router EAGRP is number 10 network 172.16.12.0. Now see, between branches how many paths we have? We have 2 paths, but we have configured default route towards
DC.
VPN interface, right? Means all the internet traffic, cloud traffic will only go over internet, not over MPLS. I am going to remove the default route from all the branch routers. Here say do so run section IP route. I can say no to this command. And on router number 3 also configure to do so run section IP route. Say no to this. And now what I want, router 1 means DC router should advertise one default route to branches for internet access. You all know how to redistribute or advertise default route in EAGRP. Now again branches cannot access internet. Interface G0/1 IPNet inside, oh sorry, outside. I have configured MPLS interface also as a outside interface. Interface G0/1 IPNet outside. But internet is not accessible because default route is not there. If I am going to ping 8.8.8, it will check routing table. In the routing table, there is no any route where 8.8.8 is matching. So I want to redistribute default route. Now on router number 1 on the DC route, if you will check EAGRP routing table, so IP route EAGRP. Here you can see 20 submit. All the 20 submits are reachable by through MPLS transport. Why? For that you have to check topology table, EAGRP topology table. So IP EAGRP topology. Here you can see for 20.1.1.0 or 30.1.1.0, there are 2 paths. One over MPLS, one over internet. Our internet, you can see here is the metric. Our MPLS, here you can see the metric. And if you want to manipulate the path, you know how to manipulate path in EIGRP, right? I can use offset list. For load balancing, I can use variance. I can use, right, any path manipulation mechanism, or we can even filter the route as well, right? First, I want router 1 should advertise default route. How to redistribute default route in EIGRP, guys? Default information originate command will work. Will it advertise default route? See, if you have any confusion in routing, like legacy routing, it will be difficult to understand SD-WAN then, guys. I must tell you. See, default route is not advertised. Even on the router number 1, after running this command, you can check EIGRP topology table. Do so IP EIGRP topology. Are default route there? Not there. So do so IP route. Okay, here I have one default route which is 0.0.0 is reachable via this interface. So this is a static route. If I will redistribute static, will it advertise default route?
Yes, I think.
Here you can see now default route is coming, but this default route is coming through MPLS. If you want to forward traffic over internet, you can perform path manipulation here in EIGRP. See how branches are accessing internet or cloud application. It can access through both. Even you can configure load balancing, right? Or you can perform path manipulation for a specific prefixes, like let's say this prefix 20.1.3.0. User from this submit, these are critical users should access internet through MPLS. Rest all the users should access internet through internet. You can do these all kinds of manipulation here, and that is path manipulation. That is the policy. In SD-WAN also we will do that, but here you have seen we have configured all the router individually. In SD-WAN we are going to configure it centrally, and the policies are so flexible. But most important thing is these two are only transport which is connecting multiple sites together. This is not the internet, right? This is not the internet. Now what will happen in SD-WAN, how it is going to work? Let me show you. See, you have same side, DC side. Here I am going to use SD-WAN router now. SD-WAN router, branch 1, branch 2 and branch 3. VH1, VH2. In SD-WAN we have two types of router, VH or CH. Viptela Edge or Cisco Edge. Okay. Now here I have transport. The very first thing which you need to understand over here in SD-WAN is we don't have control plane on these routers. We cannot configure routing protocols like EIGRP over here, right? Between internet or MPLS and my router. All the control plane is now centralized. Here you have to learn two software. One is vManage and one is vSmart. vManage and vSmart. Remember, for all configuration we are going to use this software. For all management related task will be done through this centralized dashboard, centralized software. and all the control plane things will happen through this vSmart. All your managed routers means VS1, 2, 3, 4 will first find the IP address of vManage and vSmart. Let's say vManage IP address is 100.1.1, vSmart IP address is 200.1.1, and if here I have configured public IP address 1.1.1, here 1.1.2 or 2.2.2.1, here 3.3.3.1 and 4.4.1. So like here, all the public IP addresses will be reachable with each other. That is the concern of ISP, not our concern, correct? VS1 can ping vManage, can ping vSmart, can ping VS2, VS3, VS4. Am I right?
Yes.
All are using public IP address. They can ping. If you are using private IP address, you have to configure NAT as static NAT. That is also our scenario. We'll see. Here, everywhere I'm using public IP address, all will be reachable. First, all the VSs are going to discover the vSmart and vManage. Who is my vManage and who is my vSmart? How it will discover? See, in legacy,
Smart.
no vSmart. In legacy time, we had three types of plane: management plane,
Control plane.
control plane, and data plane. Here in SD-WAN we have one more plane, orchestration plane. Orchestration plane is for authentication. See, earlier all the plane was residing inside the single box. Now your management plane is here and your data plane is here, your control plane is here somewhere else. Right? Maybe vManage, you can deploy vManage on AWS, or in your data center you can connect on the internet, vSmart on Azure, right? And all have public IP address, all are reachable with each other. But as my multiple planes, control plane, management plane, data plane are connected through transport, internet, through public network, this is not secure. We have to consider security very carefully here in SD-WAN, because my planes are distributed, are deployed somewhere else, and all the planes are reachable through internet transport. That's why here we have one more extra plane, orchestration plane, that is only responsible for authentication. vBond works on orchestration plane. Which device? Which software? vBond. vBond is also one software only. vBond will have the knowledge of vManage and vSmart. What is the IP address of vManage? It knows 100.1.1 is the IP address of vManage. What is the IP address of vSmart? It knows vSmart IP address is 200.1.1, and the IP address of vBond is, let's say, 101.1.1. So I am going to tell you, are going to configure on routers that what is the IP address of your vBond. I will say, hey VS1, the IP address of vBond is 101.1.1.1 on all the router, right? This is the part of onboarding, right? And there are some automated method as well, like PNP or zero touch provisioning. In PNP and zero touch provisioning, plug and play or zero touch provisioning, the routers will automatically discover the vSmart even, right, through ISP. It will resolve on domain name piptela.ztp.com, and it will find the IP address of vBond. In the manual method, first we'll understand the manual onboarding. In manual onboarding, we are going to configure the IP address of vBond. As soon as we will configure the vBond IP address, your router, VH router, is going to establish a tunnel with vBond, a secured tunnel, by using either TCP or UDP protocol. All of you know the TLS and DTLS protocol. TLS and DTLS protocol, these are control connection. right? These protocols are used to establish control connection.
Yeah.
So what will happen? VS, as soon as VS will discover the V bond, it will establish DTLS or TLS control connection, and now they will communicate through this control connection. Inside this control connection they will send the data that is secure, completely secure. First, once it will establish control connection with V bond, it is going to validate their self, right? That hey, see, this is my identity certificate. In SD-WAN we are using certificate for validation. Certificate, I will talk about this also in onboarding. So VBond is going to share their identity certificate to VBond, that this is my certificate, please check, am I authorized person to join the fabric or not. VBond will authenticate VS1, and if authentication pass, then VBond will share the IP address of vManage and vSmart to your VH, to VH. Now VH knows what is the IP address of vManage, 100.1.1.1. It will establish one control connection with vSmart. Got it? It will also get to know about the IP address of vSmart. vSmart IP address is 200.1.1.1. It will also establish one control connection with vSmart. And now it will break this control connection. This control connection was temporary, but these two control connections are permanent. One control connection with vManage, one control connection with vSmart. Why with vManage? To push the configuration so that you can configure VS1 from vManage by using a management protocol called netconf. Inside this control connection, netconf or restconf, these protocols will work, right? Through netconf you can push the configuration from vManage to vSmart. And for the routing, for control plane information, it is going to establish OMP session. OMP routing protocol will work automatically inside the control connection, this control connection between vSmart and VS1. Similarly, VS2 is also going to validate themselves to vBond, and it will find the IP address of vManage and vSmart. Then it will establish one control connection with vManage and one control connection with vSmart. This VH is also going to establish one control connection with vManage and one control connection with vSmart. This way is also going to establish one control connection with vManage and one control connection with vSmart. Guys, this is what? This is your SD-WAN topology. The topology right now which you are able to see, the overlay which are designed over physical network, over underlay. This is what, these all are the virtual tunnels, right? So this connection is temporary. All the managed router will first find vBond. With vBond they will establish control connection. They will prove their identity. If authentication pass, then vBond will share the IP address of vManage and vSmart. After that, all your router will have control connection with vSmart and vManage. That is permanent control connection. That is permanent control connection. Now, if I will remove underlay from here, then your topology is going to be like this. If I will remove underlay, here is VS1, VS2, VS3, let's say two sites only, two sites and one DC. Let's make it simple. VS1, VS1, 2. Before next class, I want you guys to revise the control connection, DTLS protocol, TLS protocol. Like these protocols works with works like your routing protocol, like OSPF sends hello message. Similarly, to establish control connection, also two devices are going to exchange some message, hello message. They will verify some parameters. If parameters will match, they can establish the control connection, right? So these are my routers, and somewhere we will have this software vSmart and vManage, right? I have removed one vBond here, right? That is for authentication, works at orchestration plane. Right now I have vSmart and vManage. vManage and vSmart. And here you have one control connection. Here you have one control connection. Then here you have one control connection. And here you have one control connection. Similarly, here you have one control connection, and here you have one control connection. Control connection with VS and vSmart. Inside the control connection of control connection between VS and vSmart, OMP protocol will work. Here also OMP will work. Sorry, I did some mistake here. This is control connection with vManage, and here is a control connection with vSmart like this. Okay. Between branch routers and vSmart, we have control connection. Inside that control connection, OMP protocol is going to work, and between vManage and Vantage router, I have one control connection. Inside that control connection, netcon protocol will work for configuration, for management related task, right?
Yeah.
Like you can SSH router from vManage, right? So SSH, we will allow SSH protocol on this terminal interface. Whatever protocol will allow, you will see that in upcoming classes. Now you can see all the routers don't have OMP session with each other, but they have OMP session with vSmart OMP. Now behind VS1 I have one LAN subnet 10.1.1.0/24. So what will happen, guys? VS1 is going to advertise this subnet to vSmart through OMP protocol. OMP is dynamic routing protocol, SD-WAN dynamic routing protocol. VS1 will advertise this prefix to their OMP neighbor. Who is their OMP neighbor? vSmart. And vSmart will reflect it to their other neighbor, VS2 and VS3. So this way VS2 and VS3 is going to learn DC LAN. Okay. And like we have next hop IP address here, we have configured routing in my topology. Here we have configured what? Routing using next hop IP address. In SD-WAN, instead of next hop, we are going to use T-lock. All the router will be having T-locks. Like if one VS is connected with internet transport only, that means it is using single T-lock. You can see branch 1 router has how many transport? Connected with 2 transport. G0/0 is connected with internet, and G0/1 is connected with MPLS. If any remote site user want to send traffic in branch 1, they will send traffic through the next hop IP address which is running on VPN, right? Either they can send on the VPN IP address of internet or the MPLS interface IP address. Means two paths are there, two next hop are there to send traffic in branch 1, in branch 2, and the DC. Correct? In next class, I will make you understand the T-lock also. Let's say for now, all the routers are connected with ISP. Here, this is my ISP internet. And the transport locator is called T-lock, the unique identity of transport here. And I have one ISP over here connected like this. Okay, let's say G0/0. G0/0 0 is connected with internet. These are VPN interface. These are not physical interface, correct? Here
Yeah.
is the physical interface. From this interface, it is going to discover vManage. Here is the physical interface, G0/0 and G0/0. All these transport interface will have transport locator unique identity that is called TLOC. I am assuming TLOC 1, TLOC 2 and TLOC 3. TLOC 3. This transport side interface, transport locator. So routers are not going to advertise these prefixes only. OMP also advertise TLOC. VS1 is going to advertise TLOC1 to VSmart, and VSmart will reflect it to VS2 and VS3. So at the end, all the VSs will have TLOC of each other. For the data plane, this is control plane and management plane. For data plane, you know what will happen now? Once VS2 is going to learn TLOC1 and TLOC2. Sorry, not TLOC2, TLOC3. TLOC2 is self advertised TLOC. VS2 will learn these two TLOCs. VS3 is going to learn TLOC1 and TLOC2. And VS1 is going to learn TLOC2 and TLOC3. Once they will run the TLOC, like VS1 is going to learn TLOC2 and TLOC3, what it will do, it will establish IPsec again automatically. TLOC1 will have one IPsec with TLOC2 and one IPsec with TLOC3. Similarly, TLOC2 will have one IPsec with TLOC1 and one IPsec with TLOC3. Similarly, VS3 will have one IPsec with TLOC3 to TLOC1 and one IPsec between TLOC3 and TLOC2. These are the IPsecs for data plane. So if I will talk about the data plane topology between branches, VS1, VS2 and VS3. VS1, VS2 and VS3. Automatically VSmart will help them to exchange TLOC. After that, VS1 will have IPsec here. I had shown you TLOC1 will have one IPsec with TLOC2 and one IPsec with TLOC3. VS2 will also have one IPsec with TLOC1, one IPsec with TLOC3. This is what data plane topology. Now if there is a subnet 10.1.1.0/24, 20.1.1.0/24 and 30.1.1.0/24, all has TLOC, or I can say these are IPsecs. IPsec and IPsec. It will form full mesh SD-WAN topology, full mesh IPsec. So if now branch 1 and branch 2 want to communicate, they will communicate through this IPsec. Branch 1 and branch 3, 1 DC will talk with this IPsec, right? So you can see they have direct IPsec between each other, between all the branches. And how they have exchanged the TLOC and out through VSmart using OMP protocol. How you can manage all the routers through vManage through netcon protocol. But remember, these all protocols are running inside the control connection. Okay, this is the foundation fundamental of SD-WAN. Tomorrow I will discuss this all topology again, and I will show you practically. When you will see the practically, you will understand everything, all the process. During onboarding, I will show you how we are going to authenticate VANED devices to VSmart, how it will find the IP address of controllers vManage and VSmart, how they will establish control connection, and we'll verify all the control connections as well as IPsec. Then we'll check the connectivity between multiple sites. Till then, whatever I have discussed today, if you have any confusion in these things, like in the DTLS protocol or TLS protocol, or in the IPsec, right, or the legacy configuration, legacy WAN configuration, this topology, then you can go through that concept, right? Just search that topic on the internet, watch a small video, or read the article. You can understand those things. From tomorrow I will start our SD-WAN. Ask if anyone have any question. Otherwise, that's all for today from my side.
So, Praful, even in my company, we have sites, right, and data centers. So, for each site, we have dual ISPs, dual circuit. So, what does that mean? Like the users from the site, if you want to communicate to internet, they will use data center. Is it?
This is the dual side, like dual transport setup. Dual
Yeah,
transport
that's
setup
what.
means there are two paths between two sites.
Mhm. So that's what. Like, so if they want to communicate to internet, then they will use the data center.
Correct?
Via, okay. So from the site, they will not be able to communicate to internet.
Correct. Here we don't have
Okay.
direct internet access. Here you can configure direct internet access as well, but you need
Hmm.
firewall for that. Here you should
Okay.
have firewall. Okay. And your SD-WAN routers already has firewall features. So we can enable firewall features over here. We don't need dedicated firewall. Here we can configure direct internet access as well. Right? So direct internet access is our policy, one policy in SD-WAN. Later we'll see that. Okay. Anything else? Do you guys need this command?
Yeah, we need it, but I don't have my PNet set up yet.
You can set up this lab in GNS3 as well if you have the GNS3. For PNet, I am sending you on URL, or just watch a small video, sir, how to register on PNet. It's easy. As soon as you will register, you will share the mail ID. I will give you the access to my lab. You can directly access in the browser.
Yeah, I actually did, but it's just to everything is working, but I couldn't